Probably the most challenging situation where you'll be asked to find the median would be where you have a frequency distribution table, like I've drawn here, and you're told that your data is continuous. So remember, continuous data, easiest way to think about that would be measured data. So what I mean by continuous is that we don't actually have jumps between the possible values here. For example, if this was something measured, let's say I'm measuring the width of some objects, or I've asked a number of people to write their name on a wall, and I measure how many centimeters high they use to write the letters in their name. Some people might write their name small, 1 inch on average, or 1 centimeter, and some would make very large letters. So something where you're measuring. Now, measurements don't have to be either, let's say we're dealing with centimeters, it doesn't have to be 1 centimeter, or 2, or 3, or 4. We could have values in between these. Somebody could have written their name 2.2 centimeters high, or they could have used letters that were 3.875 centimeters high. But perhaps we're not interested in carrying as many decimal places. We just want to categorize them into these groups. So we've got, we've rounded things to either 1 or 2 or 3 or 4 or 5 centimeters. But even though we've rounded things, we are dealing with continuous data. Now, continuous data challenges us a little bit when it comes to the median, because even though we normally would just find, if we had to find a median that was between two numbers, we would just take the average. You're not supposed to do that with continuous data. Instead, the median, to find the median, you have to use interpolation. Now, I showed you how to do that earlier. Interpolation, in this case, to find the 50th percentile. And so you may remember that there's a fair bit of work involved in doing that. So let's have a look at what we would do in this case. Now let me just get rid of this. That's not really relevant to this particular example. If this was my data set and I'm looking for the 50th percentile, the first thing that I have to do is I have to find my cumulative frequencies, starting with my lowest value. So let's make this a little bit easier to follow. 1, the number of ones that I see in my data set are 2. So far, starting from the bottom, I've got 2 scores covered. By the time I get to the end of my 2s, I've added another 2 scores, so we have 4 scores. 4 scores are equals to or less than 2, although rather, I should say, considering that this is continuous data, we have to think of the upper real limits. So 1 has an upper real limit of 1.5. 2 has an upper real limit of 2.5. And so 4 scores are equal to or less than 2.5. Anything that's above 2.5 would get categorized into the next category up here. I would round it up to 3. Anything lower than 2.5, I would round down to 2. So I'll just put my upper limits here, my upper real limits. So 4 has an upper real limit of 4.5. 5 has an upper real limit of 5.5. And so going back to my cumulative frequencies, I add another 2. 6 scores are less than or equals to 3.5. Add the next 3. 9 scores are less than or equals to 4.5. And finally, add the last one. 10 scores are equals to or less than 5.5. Now I change these into percentages. I'll call that cumulative percentage. So this is just 20%, 40%, 60%, 90%, and finally 100%. When you're doing this, the last one should always come out to be 100%. Now what we need to find is the 50th percentile. That is, when we find that, the 50th percentile is the median. But you can see that the 50th percentile is not listed here. If it was, if this one, instead of saying 60, actually said 50%, what that would mean is that my median corresponds to this number here, the 3.5. But it doesn't say 50, it says 60. And so all that I know is that 50% is somewhere in between these two. What I'm going to do is I'm going to take this relevant part and reproduce it over on the side. So I'm going to have my 3.5 is the upper real limit that goes with 60%. And then the 2.5 is the upper real limit that goes with 40%. Now what I'm looking for is the median. The median is at 50%, which is halfway between these two values. And so the score that I'm looking for is going to be whatever is halfway between those two values. So what is halfway between those two values? Well, the distance from here to here is the total distance to get from 2.5 to 3.5. This might seem easy, but I just want to do this properly. Is 1.0. That's the total distance, is 1.0. I only want to go halfway because to get from 40 to 50, I only went halfway to 60. The distance from 60 all the way down to 40 is 20, but from 60 to 50 is 10. To get to the 50, we're only going 10 out of the 20 of this that spans this entire distance here. So we're only going halfway here. So halfway, 0.5 times 1 is equals to 0.5. I have to take my 2.5, start there, add the 0.5, and it gets me to 3.0. So my median is equals to 3.0. Okay, so in this case, interpolation didn't turn out to be a very big deal. It worked out nicely that 50 was right between 40 and 60%. I didn't really intend to make such an easy example. I just made these numbers up right before starting this video, and it just happened to turn out that we got a nice even number and that 50% was right in between, halfway between 40% and 60%. So I'll make sure that when I'm doing a practice question for this, I choose something that's a little bit more challenging, and of course I'll walk you through that one as well. So remember, when you have a frequency distribution table, or if you simply have continuous data that you are asked to put into a frequency distribution table, and then you're looking for the median, you're going to have to find the 50th percentile using interpolation.